Hello, everyone. Welcome back. Today, we're going to be starting our EQAO practice. So, I'm going to go through EQAO practice for all different concepts. Today's concept is geometry. So, I'll be going over some various multiple choice questions and also some open response questions as well. A lot of this is either based on what we've learned in this course already or based on things that we've learned as prerequisites to this course already. So that's the goal, is to see how much we know and to review what we already know for the EQAO, which is a standardized test. Okay, so let's go to the top. It asks, according to Pythagoras' theorem, what is the length of the third side of the triangle? So this would be an example of a question we've perhaps done in middle school, right? It's a little bit before grade 9. So how would we answer this question? Well, we know that Pythagoras' theorem is a squared plus b squared equals c squared. And in this case, we have a squared. We don't have b squared, but we do have c squared. So we have that 15 squared plus b squared equals 17 squared, right? So that means b squared is 17 squared minus 15 squared. So b squared equals 289, right, which is 17 squared, minus 15 squared, which is 225, right? And so that's going to be, b squared is going to be 64, which means b is 8. So therefore the answer would be D or 8. Okay, so for this one, as long as you understand how to use Pythagoras' theorem, you'll be good with this kind of question should it come up. If Pythagoras' theorem is unfamiliar, I do strongly recommend reviewing it, as Pythagoras' theorem is a classic thing that comes up on the EQAO every single year. So it's definitely something you want to know for that. Okay, let's move on to number 2. The diagram to the right. What is the x value? Okay, so that's a good question. What is the x value? Well, what do we know? We know that the angles, that the three angles here must add up to 180, right? We also know that this angle and this angle are opposite angles, and so they're going to be the same. And we also know with our Z pattern that if this angle is 68, that means this angle is also 68 degrees, and that since this angle is 61, this angle is also 61 degrees, right? They mirror one another there. And so what would x be? Well, we know that x and x plus 61 must get us to 180, right? X plus 61 equals 180. So therefore x would be 119, right? So 119 is going to be the answer. The other thing is that clearly this is not an acute angle. Clearly this is an obtuse angle. So right off the bat, we can rule out that it's either 61 or 68, as that wouldn't really make any sense. Very good. So once again, it is D. Okay. So let's move on to number 3. It says, the following figure is a 15-sided regular polygon. What is the value of x shown in the diagram? Okay, so in order to find out what x is, we know that x is supplementary with this angle here. We also know that it's a regular polygon, so all these angles must be the same thing, right? Now, going back to our geometry unit, we actually went over a formula for finding out the total, the total number of degrees of all the interior angles, right? So that formula was n, the number of sides minus 2, times 180. So in this case, n is 15, right? So it'd be 15 minus 2 times 180, which is 13 times 180, which is, let's grab our calculator, let's figure that out, 2,340, right? And then what we must do is we must divide this number by 15. So 2,340 is the total number, and we can divide by 15 and get 156 degrees because we know something, right? We know that all of the angles are the same because it's a regular 15-sided polygon, right? So all of these are 156, 156, 156, and so on. Now, the only one that actually matters that we really care about is this one up top because they want to know what is the angle x. Well, we know that this straight angle here, this line, that 156 plus x must equal to 180, right? So that means x must be 24 degrees. Okay? So x sorry. X must therefore be 24 degrees. So the answer is A for this one. Awesome. All right. Let's move on. Oh, what is the value of x in the diagram? Well, what do we know about the diagram? We know that since we have an isosceles triangle, that means that both of these angles here must be the same because the two sides adjacent are the same, right? Those two sides are the same thing. So to find x, we know that 38, that all three of these sides, 38 plus x, all three of these angles must add up to 180. And so if we solve this equation where we're adding up 38 and then x again and getting 180, we can figure out this answer here. So 180 minus 38 gives us 142. So 2x would be 142. And therefore x, we'd have to divide that by 2 and get 71 degrees, which is B. So therefore our answer is B for this one. Okay, now what about number 5? So number 5, the sum of the interior angles of a polygon is 2,700. How many sides does the polygon have? So remember, the number of sides minus 2 times 180 tells us the total the sum of all the interior angles in a polygon. In this case, that number is 2,700. So this is really similar to question 3 up here, except instead of asking for the supplementary angle to one of the interior angles, what they're asking us for is n, is how many sides does it have? So what's our value for n? So the first thing I'm going to do is I'm going to divide both by 180. So what's 2,700 divided by 180? It's 15. So n minus 2 is equal to 15, right? And actually, let's make more clear how I got there. If we divide both sides by 180, then I get n minus 2 is equal to 15, and therefore n is equal to 17. So the answer is 17. Right? And that makes kind of good sense, and it's consistent with here because for a 15-sided one, we said that the total was 2,340. And so here, if the total is more, then that means it must be bigger than that. And that is consistent there. Very good. All right, let's move on to the last multiple choice question here, which is multiple choice question 6. Consider the diagram to the right. What is the value of x in the diagram? Okay. So first of all, we know that here we have an angle of 30 and that this angle plus whatever this angle here is must add up to 90 degrees because we have this right, this is a right angle here, this full thing, right? So these are complementary angles. So therefore, this angle here must be 60 degrees, right? We also know that the three angles of a triangle in total must add up to 180. So that means x plus 60 degrees plus 37 degrees must be equal to 180, right? Because these are the three angles in one of the triangles here, okay? So now we're going to say x is equal to 180 minus 60 minus 37. And let's punch that in our calculator and see what answer we get. So that's 180 minus 60 minus 37 gives us 83 degrees. And so therefore 83 degrees is the correct answer for this one. Very good. Okay, now let's move on to some open response questions. Number one, a schoolyard. A schoolyard is in the shape of a regular decagon as pictured. So decagon is a 10-sided polygon, and it says regular decagon. So what does that mean? That means all sides and all angles are the same because it's regular, okay? Whereas an irregular decagon means that the sides and angles are not necessarily all the same. Complete the chart below with values of x and y. Justify your answers using geometric properties. Okay, so if it's a decagon, the first thing they want us to find is what one of the angles is. Now, to find out what one of the angles is, if we figure out the total number of degrees, it's the sum of all the interior angles, and then we divide by 10 because there's 10 angles total, we can find y. Okay, so to do this, we have 10 minus 2, right? Because 10 is n, times 180, and that's going to give us our total number. And then we're going to divide that by 10 in order to get the degrees for just one of the 10 angles, right? Because again, all the angles must be the same, so all of the sum must be evenly divided amongst all 10 because it's a regular decagon as opposed to an irregular decagon. So we're going to punch in 8 times 180 divided by 10 here to get 144. So therefore y is equal to 144 degrees. And the properties we use there is we use this equation to figure that out that tells us about the interior angles. Now, what about x? Well, just like this one's 144, we also know that all of them are 144, so we could write that for all of them. I'm just going to write them, where it might be relevant here or we might care. So if this is 144 and this is supplementary with this angle, what must this little angle be here? Well, this little angle must be 36, right? This little angle is 36 degrees because 36 plus 144 gets us to 180, and that's what we need. We need 180 for that straight angle. We also need 180 for the three angles in the triangle, right? So we know that 36 plus 90, right? Because we have this here, which tells us that this is a 90-degree angle, plus x must give us 180. So now if we do x is equal to 180 minus 36 minus 90, we can find out what x is. So 180 minus 36 minus 90 is 54. So therefore x is 54 degrees. Awesome. So therefore, I'm just going to write a quick conclusion. X is equal to 54 degrees, and y is equal to 144 degrees. And there we go. Okay, let's try this one. This one says daring diagram. A diagram is shown right. Find the values of x and y. Justify your answers using geometric properties. Well, in this case, it's not regular, right? However, we actually do have enough information to figure out x and y even though it's irregular, okay? Because we know that these are both 100 and we know that the three x values are the same, right? So if we figure out what is the total number of degrees of the sum of all of these of x plus x plus x plus 100 plus 100, if we find out what that sum is, we can take that equation and we can use it to solve for x. So what is the number of degrees of a pentagon? You might have it memorized and know that it's 540, but in case you don't, I'm actually going to go through how we would figure that out and solve it. And either way here, since it's not as simple as, since it's a little bit more complex than just a triangle, for good measure on EQAO, even if you haven't memorized that it's 540, I would still show how you know that using the geometric properties to get full marks for that. So yeah, the only one you wouldn't have to prove is the triangle one, I think. But the other ones, for good measure, I would write it in anyway. So here we would have 5 minus 2 times 180, which is equal to 3 times 180, which is 540. So therefore, the sum of the angles of a pentagon is 540, right? So what does that mean? That means x plus x plus x, plus 100 plus 100 is equal to 540. And if we clean this up a little bit, we'll see that this is the same as 3x is equal to 340 if we subtract those couple hundreds off. And then if we do 340 divided by 3, we will get 113.33 degrees. And that's what x would be. Now, what about y? Well, y is actually, in this case, quite separate. We actually don't need what we learned up here to find y. It's really two separate questions here in a sense. So they're kind of pushing into one to see if we relate the two or not, but they're actually unrelated. In this one here, we must add up all four of these to get 360, okay? Because the area of any, or sorry, not the area, the sum of all the interior angles of a quadrilateral or a four-sided polygon is always 360. So for y, we can say y plus 85 plus 70 plus 90 must be equal to 360. So therefore, y is equal to 360 minus 90 minus 70 minus 85. So let's plug that in. So 360 minus 90 minus 70 minus 85, which is 115 degrees. And there we go. Awesome. And I guess that one we could use the formula as well. I'm not too concerned about it. I do feel like it's a well-known fact that, for any quadrilateral, it's 360. However, if we did want to show that, we could plug this in as well and say 4 minus 2 times 180 is 2 times 180, which is 360. So we can use the formula for this as well if we'd like. Very good. Let's move on to one last one, and then we'll be done with the geometry section of our EQAO practice. This says diamond cut. The diagram below, the diagram right shows a regular decagon with 3 isosceles triangles. Determine the value of x and y. Okay, so let's start with determining the value of x. So they told us it's a regular decagon, and we actually already solved up here for how many degrees for a regular decagon. So because we already did that up here, I'm not going to show it again. I'm just going to say this must be 144 because of reasons above, right? We already have solved this. Now on the actual EQAO, I'll be clear, they're not going to give you the same question twice, or they're not going to be so simple about it, I don't think. They're going to, they wouldn't give both of these questions. We're just doing multiple different types of these questions to get more practice in. So this would be 144 for reasons above. Now, given that this is 144, what does that say here? So again, they're actually unrelated here. They would like to know what is y. So in this case, we have 14 degrees here, and we know these two are going to be the same thing. So I'm just going to label them as, let's just say alpha and alpha. And we know that alpha plus 14 must equal 180 degrees. Now, how do we know that? Because all three of the interior angles of a triangle must be 180, right? That's a little known fact we have. So that means that 2 alpha is equal to 166. So therefore, alpha is going to be half of that, which is 83. Very good. So that means these are each 83. And by extension, that means that these are also 83 and 83 because we have these parallel lines here. So by that property, we know that it's 83 as well, right? So by by our knowledge on isosceles triangles and also by this property, we can conclude that y is also equal to 83. So in conclusion, x is equal to 144 degrees and y is equal to 83 degrees. Very good. Okay, so that's it for today with the EQAO geometry questions. Next day, we'll talk about some linear algebra questions. So I will see everyone for that day. Good work today, everyone, and bye for now.